Let's dive a bit more in technical topics regarding foundation models. And in particular, today we will see the encoder-decoder framework. What we will see today is what was before the LLMs, in particular, what they are called recurrent neural networks. We will highlight a particular architecture known as sequence-to-sequence architecture, and finally we will describe a derivation of all these concepts into the encoder-decoder architecture. Let's go step by step. What was before LLM? Before transformers, recurrent architecture were widely used in analyzing sequence and in particular text. This architecture have loops that allow the information to go step by step from previous to next, making them suitable for analyzing sequencing data. In particular, one architecture known recursive neural network, which links is in the slides, take input, process it through the neural network, and produce what is called hidden state vector. A recursive neural network shares information with itself through loops, enabling to retain the information and to use past information to make prediction at each step. In this picture, we see a graph of a recurrent neural network where we see that for each cell of the neural network, there is an input that generates a state. The output of the cell is passed step by step to the next cells until reaching the end. This architecture generates what is called the sequence-to-sequence modeling. In fact, RNNs have been instrumental in developing machine translation systems which aim to convert sequence of words from one language to another. This is typically achieved by a sequence-to-sequence architecture which is well suited to handling sequences of variable lengths, both in input and output. The first stage of the model is responsible for converting the input sequence into a numerical representation known as the last hidden state, which passes all this information through a second stage that generates the final output. An example, the first stage of a sequence-to-sequence architecture known as encoder and the second stage known as decoder can use different neural network capable to handle sequence. This is an example where a recursive neural network takes as input an English sentence, such as transformers are great! And through the hidden state, pass this to the decoder network that translates the sentence into German. The input words are sequentially processed by the encoder, while the output words are generated one at a time from a top-to-bottom fashion by the decoder. What's the drawback of this type of architecture? The sequence-to-sequence architecture of RNNs in particular suffer from an information bottleneck issue, where the final hidden states of the encoder must encapsulate the entire meaning of the input sequence. Of course, you can understand that this can result in loss of crucial information, especially for longer sequences. The introduction of mechanisms such as attention provide a solution to this problem. So the original transformer architecture is basically a sequence-to-sequence architecture that consists of two main components. The encoder that takes the raw input as text, breaks it down into fundamental components, the tokens, and convert them into vectors, into numbers, and use the attention mechanism to understand the contextual meaning of the sentences. On the second stage, there is the decoder that generates the output text and employs a modified form of attention to predict the most suitable tokens, allowing for the generation of coherent and meaningful outputs. Variants of this architecture are the modern LLMs, such as BERT and GPT. These models focus on or the encoder or the decoder component to specialize in tasks such as understanding and generating text, respectively. In particular, architecture based on the only encoder are great at understanding text. This is what we call auto-encoding architecture in a previous lecture. On the other hand, architecture based only on the decoder stage are very good at generating text. And this is what we call autoregressive model in previous lecture. Of course, we can combine these two aspects. The combination LLMs like P5 integrate both autoregressive and autoencoding components, leveraging the versatility of the encoder and decoder to generate text in a more flexible manner. These models are capable of producing diverse and creative text by capturing additional context through the encoder and surpassing pure decoded-based autoregressive models. This is an example of how an encoder-decoder model is generated. What we learned in this lecture. Before Transformer, recurrent architecture were widely used in analyzing sequence and in particular text. Sequence-to-sequence architecture are well suited for handling sequences of variable length, both in input and output, and the combined encoder-decoder architecture is capable of producing more diverse and creative text than only encoder or decoder architectures.